Hello everybody, I'm Raul.
I'm Oscar.
So we want to talk about special products. With special products, we have the problem of x plus y plus c plus 10 times x, y minus z minus 10. Now,
The first thing you have to do is to basically identify what type of binomial, trinomial, polynomial it is. First, it is a binomial to the square? No. This doesn't have a square, so it's not. Second, is it a binomial to the cube? No, this is not a binomial. So we're gonna discard all about them. So let's see if it can be a conjugated binomial. A plus b times a minus b. Okay, at first glance it obviously doesn't look like that, but let's arrange some variables and see if it can. Of them is not a special trinomial, so then where it is? Well, first we have to learn how to separate things. So let's do it.
Hey Oscar, so what's the difference between one and the other one?
The signs, bro. The signs is the difference. As you
So
can
what
see,
will it be? Will it be a conjugate binomial?
maybe, but at first glance it doesn't look like it. So let's please start separating. So let's take this off and just add a parenthesis here and a parenthesis here. So these are the same binomials, so maybe this can be equal to a binomial to the square, right? Okay, so now we got that up. So what's the formula of a binomial to a square? Well, it's a squared plus 2ab plus b squared. So it's basically x and y, so we can do the same thing. So we will get x squared plus two a 2x y plus
Y square.
yes y to the square.
Now, with what we just got, we do the same to the other thing, with one simple trick. As all is negative, the sign is gonna go down. So instead of being a negative binomial, you're gonna do a -1, parenthesis, and the other part of the binomial. In this case, would be a trinomial.
Yep. So now, but what happened to the other digits, you may be asking? So let's check that out. So as we already got this type of trinomial, we have to move on. So yeah, let's go.
Now, designating a and b, which in this case will be 10 and z, you take the negative out, so you will get a common equation. Will be 10 plus c, z. As you can see, they're conjugate binomials.
Yep, this arranged very well to the formula, so let's see if we can make it work.
Now, we're gonna add both equations. Oscar, would you kindly multiply this by a -1, as of that negative that's outside, because of the formula that is a squared minus b squared. Now, normally, as you would always do, add the x squared plus 2yx plus y squared.
Okay, so the next problem is going to be about radicals. So we're going to have 3 different radicals with 3 different indexes.
3 radicals with different index that we have, we can change them all to the exponential radical equations, which in this case are 2xy with every single one of them. Now, what do? We add, well, multiply actually, but as we are multiplying exponents, we add the exponents. So multiply the exponents, that will give you.
But wait, Raul, how do you got the 256 to become a 2?
Well, you use prime factors, as many prime factors as you need. In this case, 256, you can prime factorize it 2 times 8. You can factorize 2 8 times. So, that being said, that will give you 2 on top of it, with a 8 on top. Now, you might ask also, how do I get the 4 over x, the 8 over 4? Now, that's a good question. It's the exponent over the index. Now, that being said, we're gonna add the exponents, in this case being 3 over 2, 2 over 3, and 8 over 4. Now, are going to find the common denominator, in this case being 12. Once you do that, you're gonna add them, giving you your final answer as 2. Now, we're gonna do the same with x and y.
But we also have to prove the root is bigger than the index. Is not done at all. So we have to make it, the number inside of the root has to be smaller than the one in the index.
In this case, we have 2 with a 4 outside. Now, we just did this so you can get an explanation of the 2. Now, the final answer will give you this. 2 at the power of 4 times x squared times y to the power of 4, open radical with an index of 12, 2 to the square, that will give you 4, x to the power of 11, and y